Before then, I continue the recording. Okay. Okay. So I was explaining that what we have here is like the foundation. So let me attempt to use that whiteboard now. Probably is going to work this time around. The whiteboard. Because it's important you understand this illustration I'm trying to make. Because it's the foundation of the whole thing itself. Okay? It is the foundation of the whole thing I've been trying to explain. Can you all hear me? Hello?
Sir.
Okay, great. Let's see if the board is going to load. Okay, the board has successfully loaded. So, what I said was that when you have your curve drawn this way, can you see my board? Can you see the whiteboard?
Still loading, sir.
Okay. You have seen it, let me know. Can you all see it? Can you see my board?
Not yet, sir.
I'm supposed to be seeing the board now.
We are seeing.
You can all see it now. Hmm? Can you all see it? Can you all see it?
Mine is still loading.
I can see it, sir.
Okay, good. I'm labeling it so that you can get what I'm saying. So the critical value is called the T-tab. That's the T-tab, the critical value. Okay? The value, this is the value, the Z value on our table that correspond to this particular alpha level. We call it the T-tab. Or the T critical. Okay? This is our rejection zone. We have our rejection zone. I guess you can all see what I'm doing.
No, sir.
No, sir.
How many people can see what I'm doing?
I can see it, sir.
You can see it. Okay. I'm going to do a screenshot of what I've done so far so that you can appreciate it. Okay. Check the comment section. You'll see what I've done so far. So you have the critical value, which is our T tag or T critical. Okay. That is the value we look up on the table. That's why you call it the T tag. Okay. Now, usually for statistical tests, we are going to do some calculation, which is a very important aspect you should all be familiar with. And at the end of that calculation, the answer we are going to get is called our T computed. You can call it T computed, or you call it T statistic. T computed, or you call it the T statistics. Some people will call it the T stats. Or the T cal. That's the T, the calculated T. Okay? Can you see what I'm doing? How many of you can see this? Just check the comment section. I'm posting them on the comment section for you to see.
Okay, sir.
Can you see them at the comment section?
Yes, sir.
Aha, good. These are what you are going to get at the end of your calculation. Okay? Now, if the value you got, this your T computed, if it falls within this particular 95% range, then you will retain your null hypothesis. But if it falls within this particular rejection zone, you will retain your what? You will reject your what? You will reject your null hypothesis. Let's speak in terms of null hypothesis. You will reject your null hypothesis. In other words, let's put it in another way. If your T cal or T tab rather, if your T tab is greater than your T stats, that's your T statistics, what do? You are going to what? You will retain. That's going to retain our H naught. You retain H naught. Is anyone seeing the screen? But if your T tab is less than your T statistics, that is when to what? Reject your H naught. Am I making sense? I'm going to grab the screen again and send it. Okay? You can see what we are saying there. Please take note of this particular slide. This particular slide tells you the summary of all what we are doing in differential statistics. It tells you the summary of all we are doing in differential statistics. Okay?
Okay, sir.
Now, let's now go back to our slide. Let's go back to our slide. Let's go back to our slide. Now, I said that I'm going to do an overall explanation of this so that you can all flow with me on what this whole essence is all about. The essence of all these exercises. I told you it's like having a plan. The plan of the house, And then you consult that plan as you continue your building. You follow step by step as it is listed in the plan. So I've explained the thought concept to you. That's locate the critical value. And I've showed you in practical sense what we mean by the critical value and how it is described. Are you getting it? Now, the next thing is to compute our test statistics. This test statistics, that's number 4. We are on number 4. And number 4 is going to take us weeks of explanation. Hello?
Hello, sir.
So our number 4 will take us a long time trying to explain what it's all about. But of course, the step 5 and 6 will be explained alongside with step 4. So please follow me carefully as I start. Test, statistical tests. That's the focus of this class. You have been hearing of statistical tests. We have different types of statistical tests. Okay? Broadly, they are classified into 2. We have the parametric. Can you see my screen, everybody? Can you all see my
Yes,
screen?
sir.
Good. Broadly, they are classified into 2 categories. We have the parametric, we have the non-parametric. For the parametric, they are divided into 2 areas. We have the one sample. That is when you are dealing with just a sample. What are the kind of tests you can perform on just a sample? You can perform 2 possible tests. A t-test or a z-test. In what situation can you have just a sample? A situation whereby you are given a hypothesized mean and you have to test out that particular mean. If that mean is okay, all you need to do is just to collect a sample from the presumed target population. And you want to know if what you are going to get will be consistent with that hypothesized mean. Recall that in parametric tests generally, all what we are doing is that we are comparing mean. I cannot overemphasize this. All what we are discussing is how do we compare mean you obtain from samples or from a sample. Now, the next type of parametric test or category is the 2 sample. When you are dealing with 2 samples, what are the kind of category you can have 2 samples falling into? You can have independent sample, you can have dependent sample, the one we call paired sample. I've told you what independent sample is. You are having 2 separate groups. You collect information about the social, maybe you have two groups. Each group are made up of 10 students. You want to study their attitude to social media. You collect information from group A, you collect information from group B. You find the mean, you compare the 2 mean. These 2 groups are independent, they don't have anything in common. But the pair type or the dependent 2 sample type is when you have just a group and you want to know the implication of tampering with that group or an intervention on that group. Maybe you want to know the impact of feeding them with cocaine. Before you gave them cocaine, you collected their IQ. After you are giving them cocaine, you collected their IQ. The same group of people you are collecting data from in 2 phases. That is what you call a paired sample, or we call it a dependent sample, or you call it matched sample. I hope you are writing all these things down. Hello, are we still together? Hello?
Yes, sir.
Okay, great. So the other aspect is the non-parametric test. The non-parametric test, I'm not going to be teaching you non-parametric test. Dr. Okore Kanu will teach you non-parametric test. But it's important you have this understanding, this foundation, so that by the time she comes in, you will not be looking lost. So we are going to focus on the side, the area. And that's what we are going to do. In fact, I'm not going to finish the parametric test with you. is going to take you some aspect of parametric test, like the ANOVA. Are you getting my point? So, but essentially, let's limit ourselves to parametric test. Now, what is non-parametric test and parametric test? Parametric tests essentially, they are tests that normality of your sample is assumed. In other words, if you plot a graph of your sample, you should have a bell-shaped curve. Is that clear? Hello? Is that one clear? Parametric test is a kind of test that that normality is usually assumed. In other words, if I plot my graph of my data, it should form a bell shape. It should form a bell shape. That's the parametric test. Now, having said that, the non-parametric test is the type of test that which the data does not require to fit a normal distribution or normality is not assumed. That's a non-parametric test. We pronounce it as non-parametric test. Is there any question on what I've just said? Are you clear? Some of you are not responding.
Of the non-parametric again.
The non-parametric.
So what is parametric? Yes.
I just told you that parametric are tests, statistical tests, that normality is assumed. In other words, it should fit into a normal distribution. There are types of data, when you collect them, they fit into normal distribution. They are data like the weight of a sample, the age of a class. When you plot that thing on a graph, you are going to get a curve. Are you with me? But there are some kind of data or variables that you will not get a curve. For instance, if I'm interested in the gender of your class, the gender, is either you're a male, female, male, female. If you plot male, female on a graph, will you get a curve? You won't get a curve. Are you with me?
Yes, sir.
You're not going to get a curve because there's no way you can be calculating the mean of yes and no. Do you calculate mean of yes and no? No. So we describe such kind of variables as non-parametric, and the statistical tests we use to analyze them are non-parametric statistics because they don't fit into a normal distribution curve. Have I made myself clear?
Yes, sir.
Now, if you look at this particular table, the screen, you see the parametric tests, the different categories listed for you here. You have the T test, you have the F test, you have the Z test, you have the ANOVA. Are we together?
Yes, sir.
Good. So, for our Z tests, I'm going to just explain the difference between your Z test and your T test now. Your Z test is similar to your T test. The only difference between those two types of tests is on two bases. Number one, let me try to illustrate on this screen. It's going to work. Okay. The difference between our T test and Z test. Number one is that population Number one is population. Can you see my screen? Can you see what I'm writing? Population standard deviation. Number two, sample size. Sample size. These are the two situations that differentiate between your t-test and your z-test. If the population standard deviation is known for any question given to you, what do you use? You use a test. Let me repeat myself. If the population standard deviation is assumed, is known, you will use a what? A z-test. Let me put it this way. Known. Known. You use a z-test. But if unknown, if you don't know the population standard deviation, unknown, you use a t-test. That's what your student t-test. Hello?
Hello, sir.
Good. If your number two, if your sample size is greater than 30, you use your z-test. If your sample size is greater than 30, that's when to use your z-test. If your sample size is 30 or less, that is greater than or equal to 30, you use your t-test. Is this point clear? Is this point clear?
Yes, sir.
Is there anybody that does not understand? Andriana, are you there? Andriana,
Yes, sir. Yes, sir.
is it clear to you what I've just explained?
I think.
What is not clear? I'm just giving you information. There's no logic about it. I'm just saying if the population standard deviation is assumed known, if you know the standard deviation of the population you are dealing with, then you use your t-test. But if you don't know it, you use your t-test. If the population,
Okay, sir.
if the sample size is greater than 30, then use your z-test. But if it is less than or equal to 30, use your t-test. There's nothing coding. I didn't code anything. Chinemerem, is it clear? Obiora, Austin,
Sir?
is it clear? Chisom,
Yes, sir, it's clear.
Frank, are we together?
Yes, sir.
Okay. How about Victor? Victor, can you hear me?
Yes, sir.
Is it clear to you?
Yes, sir.
Tracy, is it clear? Tracy. Tracy.
Good morning, sir.
Yes, is it clear? Are you following us?
I just joined, sir. I didn't know the class was moved to 7.
You are not on the group. Was it not posted on the group?
I didn't see it, sir.
You didn't check. You are supposed to be checking your group every morning.
Yeah,
The information I just wrote on the screen now, are you following? Is it clear? I've not explained anything more than that.
I will try and follow, sir. Just continue.
Is this information clear? If it is not clear now, there's nothing you are following again. This information I wrote on the screen, is it clear to you?
Yes, there are different types of test methods.
The writing, you are not even following this class because
I just joined now.
Okay. Okay. Anthony, is it clear?
Yes, sir. It's
Okay.
clear.
Providence, are we together?
Yes, sir.
Is what I wrote on the board there on the slide?
Yes, it's shared.
Okay, good. I'll continue. So the next thing to talk about is the t-test itself. You know, we started explaining, but we never finished last class. So again, this is the guy that came up with the whole idea, and he was able to publish his work anonymously as student t-test. Okay. Now, again, let's look at the difference between the t-test and our z-test. If you understood this last slide I just showed you, our z-test is like, you know, they both have the same curve. Your t-test, your z-test, normality is assumed. The only two difference is the population standard deviation, which if known, you use your z-test. If unknown, you use your t-test. Another thing is the sample size. If the sample size is less than 30, is 30 and less than, that's your t-test. You use your t-test. If it's greater, you use your z-test. But more importantly is the population standard deviation. This black line is your z. That's your z limit. Your z. That's your z-test, your z distribution. We call it z distribution. Okay? Why? And it is assumed that this point is our boundary of this last point is our boundary of 30, population of 30. So because when you deal with a small sample, there's need for you to make certain correction of error. That is why you begin to use t-test. Are you getting my point? It's just like when you have enough food, enough soup at home, you will tell everybody in the house, whenever you are ready, Frank, Providence, whenever you are ready, go and dish your own food, take soup and eat. That's what mommy will say now. Obiora. But whenever there's not enough soup at home, mommy will not tell you to go and be dishing your own. Mommy will rather carry the pot and share whatever is left there so that nobody will cheat the other person. That is a classical illustration of what is happening here. Whenever our sample size is small, there is a correction that has to be made. And that correction is what is accommodated under t-test. And that correction is accommodated in the form of degree of freedom. Degree of freedom, DOF. Degree of freedom. So the concept of degree of freedom comes up whenever your sample size is 30 or less than. The moment your sample size is 30 or less than, we have to accommodate for that small size. And then we begin to talk of degree of freedom. In our Z distribution, nobody talks of degree of freedom. But in our T distribution, because we are dealing with a small size sample, we begin to talk of degree of freedom. And the number of our sample size will also be affected by the degree of freedom. If you have a sample size of 20, the degree of freedom will be different. The degree of freedom will be different. If you have a sample size of 15, the degree of freedom, the lower the sample size, if the changes in the degree of freedom. You have a sample size of 10, a sample size of 5, the degree of freedom, it will begin to affect the degree of freedom. But the effect starts from when you have 30. Have I made myself clear? Is that illustration good enough for you?
Yes, sir.
Is there anybody that does not understand before I continue? The very moment your sample size is 30 and below, the idea of t-test comes up. And the degree of freedom is like an adjustment that is used to accommodate that sample size difference. But when we talk of Z-test, nobody talk of degree of freedom. So that is essentially the difference between our t-test and our z-test. Sample size, population, standard deviation. Okay? Now, another thing again we need to learn about our t-test, I've categorized them into three. And I kept repeating myself that we have basically two categories. One category is when you deal with a sample. The second category is when you deal with two samples. And you can have that one divided into two. You have the paired t-test, you have the unpaired t-test. What is another name for unpaired t-test? Can somebody help me? What is another name for unpaired t-test?
Independent.
Independent sample t-test. Independent sample t-test. What is another name for paired t-test? Can somebody else help me with that?
Dependent.
That is dependent.
Then
What other name can we call it? The paired sample t-test.
Related.
Matched.
Matched. Thank you. Matched. Matched sample. We call it matched sample. We call it dependent. You see it? Dependent. Some are indeed following me. Dependent. And we say it is before and after. Before and after t-test. Before and after. You are collecting something from the same subject. You collected it once, you wrote them down, you find the average. You collected it again, you wrote the answer. The same set of group. I hope that is clear. Good. Now, still illustrating our difference now. We have the one sample t-test. In the case of one sample t-test, we have our population. Population is here indicated. And we have a parameter we obtain from that population, which is the mean. That is our hypothesized mean. Okay? We want to challenge that hypothesized mean. A researcher is challenging me that the average age that the average age that students go, that girls get married is not 18 in Nigeria. That the average age is not 18 in Nigeria. Maybe he's saying it's even more than that, or saying it's less than that. He now decided to take a sample. He took a sample of girls when they got married, or women, and asked them when they got married, and he decided to find the average. Maybe he ended up getting 23 average. Now, when you want to test, you want to check up if the difference between 18 and your 23 is actually significant for us to disagree with 18 and reject the null hypothesis. That is what we are doing in one sample t-test. So, in a one sample t-test, you usually have a hypothesized mean. And it is just one sample you are taking. While for the other category, we have the dependent sample, which we describe again as the unpaired sample. In this case, we have two separate groups. This is group A, and another group B. Okay? You took the mean of this, X bar A. You took the mean of this other second group, you got S bar B. You are now comparing the group if there's any difference in the two. That is independent. While your paired sample, in this case, is the same group. This same group. This same group. Eh? In the first instance, you attended to them in the morning. You took information from them in the morning. Maybe you took their weight. You want to check. In fact,
Before that boy did not say the truth. And like one person was around.
who is that person disturbing us? Who is that person disturbing us? That's Chisom, Abi. That's Chisom. And very soon you will come back and tell me you don't understand what I'm saying. I'm sweating here and you are gisting over there. Okay, continue. So, looking at what you have on the screen now, you attended to a group in the morning. You took their parameters. Let's call this one money. Okay? You took their parameter. You wanted to know the effect of acne on their body weight. You took their parameter, their mean weight in the morning. You came back in the afternoon. You did the same thing. You took their weight again after you have fed them with acne. This is afternoon. You want to know what impact acne has had on them. The mean you got here is the mean of the morning period. Let's call it 1. The mean you got here is the mean of the evening period. Let's call it 2. And when you compare, because you are dealing with the same subject, the same set of people, we refer to it as a paired sample. We refer to it as a paired sample. I hope this is clear for every one of us. Any question on that? No. Any question? No. So this is what
What's
we
the
have.
difference between? No, sir.
You said?
So like between that, the difference between the independent, but like, is it based on the time of taking the parameter?
It's not time. We are dealing with the same group of people.
Okay.
The dependent sample is the same group of people you are testing. You collected parameter for them 2 times.
Okay.
That is why you call it dependent. That's why you call it paired. That's why you call it matched. But you are dealing with 2 group of people, 2 separate group of people. And you are comparing 2 separate means gotten from 2 separate group of people. That is independent.
Okay.
There's no other way to explain this thing. This thing is very basic and simple. So we say matched is before and after. And if there's no link between the 2 data, we call it independent test. So please understand. Hello? Is somebody talking?
Hello, sir.
Is anybody saying anything? Hello? Any question?
Hello, sir.
Yes. Come up. Who is that? Who is that? Who is saying hello? What do you want to have to say?
He's just responding.
Okay. So we continue. Now, for our matched and independent sample, there's another clause you need to be familiar with here. Okay? You know, we said we can have independent, we can have dependent. Now, this independent, there are 2 possibilities again you should bear in mind. There's what you call unequal variance, equal variance. two independent groups, you may be dealing with equal variance. That is, the variation among each of the groups are unequal. They may be unequal, it may also be equal. Please take note of that. This is just an information that you will need later in the course of this course. Good. Now, these are the formulas. These are the formulas for calculating the different type of t-test. And this formula, you should have it on the palm of your finger. You should know it. It should be with you. Okay? And for each type of t-test, we have different formula for calculating the degree of freedom. The degree of freedom. Number one is your one sample t-test. This is the formula for it. Your x bar minus x naught. This your x naught is your hypothesized mean that we have been talking about. Why? This is the mean of the sample you collected. This is the mean of that sample that you collected. Why? This one is the mean, your hypothesized mean, your h naught. This s is your standard deviation. Why? This n is your sample size, the number of the sample. Now, to calculate, there's also what you call the degree of freedom. How do you calculate the degree of freedom? The sample size, let's assume the number of the sample, we have 10 that we are dealing with. The degree of freedom will be 10 minus 1. It means the degree of freedom will be 9. And when you note that 9 because you will need it when you go to your table. You need the degree of freedom to check your t-tab. That t-tab I was telling you the other time, it is this degree of freedom that will help you to check it. The degree of freedom and your alpha level. Those are the two things that will help you to check the value for your t-tab. Am I making myself clear? If there's any question, unmute yourself and talk now. Ada? Ada? Hello, is that?
I don't understand this one now.
Which one don't you understand?
This degree of freedom.
I've told you that in t-test we talk of degree of freedom. Did you see the slide on the curve that I used to explain?
Yes, sir.
I told you as long as your sample size is equal to 30 or less than, then the concept of degree of freedom must come in because you are dealing with something small. I will use illustration of the soup at home. Did you listen to that?
Yes, sir.
So what don't you understand then?
This place you're talking about t-tab, something like that. I don't understand.
You didn't see the curve when I was explaining what t-tab is. Were you there when I was explaining t-tab, t-tab?
So maybe I've forgotten that one.
When I drew a curve and I was illustrating on the curve. Okay. So
I was not saying.
We'll continue. So this is the formula for the degree of freedom. That is n minus 1. The number of samples you subtract 1 from it, you get your answer. Now, the two sample tests, okay, that's the independent one. This is the formula for it already here. These are the two mean that you get from each of the samples. Okay, this is the standard error of mean. This one here. We are going to discuss them in detail. But it's important you understand them so that when we start, you will know where we are going even before we start. And this is how to calculate the degree of freedom for your independent. Remember that this one is our independent sample. This is independent or unpaired, independent, or unpaired. Okay? Or you call it unpaired. Have I made myself clear? The degree of freedom, you add the number of samples together and you subtract by 2. You subtract 2 from it. That's how to calculate the degree of freedom for your independent or unpaired sample. While for your paired sample, which is the last one, this is the formula. Okay? You first of all calculate your X bar, your difference in mean. This thing means difference in mean. This is the difference in mean. Why this is your hypothesized mean or your reference mean. Okay, we are going to discuss detail about that. Why this is your standard deviation and this is the number, the sample size. To calculate the degree of freedom, you do the same way like the one sample test. You just subtract 1 from the number of samples. But please take note, this n means your paired sample. I mean the number of paired sample. That's what this one means because we are dealing with pair test. Is that clear? Good. This is a question on degree of on one sample test. The researchers are interested in whether the pulse rate of the long distance runner differ from that of other athletes. They randomly sample 8 long distance runners, measure their resting pulse, and obtain the following data. Now, the average resting pulse of the athletes in the general population is 60 beats per minute. Now, what is that 60 beats per minute? What does it connote? Can somebody help me? What does it connote?
The mean. Is the mean.
What type of mean? Give it the exact description.
Hypothetical mean.
No, not exactly. You didn't get that.
That is by X bar.
No. That's your hypothesized mean. How can it be X bar? It is the one you calculated that will be X bar. You have not even calculated it. These are the data given to you. It is the mean you obtain by calculating this that will give you S bar. That's your S bar. But this one that they are giving to you here, that's your hypothesized mean. Hypothesized mean. Or you call it H naught. That's your hypothesized mean. Is this thing clear?
Yes, sir.
Yes, sir.
If you are not clear, let me hear you now. Obiora.
Yes, sir.
Is it clear?
Yes, sir.
Chinemere.
Look at one.
Chinemere, is it clear?
Good morning,
Austin.
sir.
Yes. What's your name?
Uche. Sir Uche.
Uche. Why not write Uche? Why putting my guy? I want to know your name so that I can call you by name.
Sir,
So Uche.
please, I'm really confused. Who call her, sir?
Huh? I'm listening to you.
Sir Uche will call. Yes, sir, I'm really confused on this T tab, sir, where you're talking about degree of freedom.
Were you in that? Were you there when I was using curve to explain the T-tab and the T-tab?
Yes, sir. Sir, but I was lost from the part where you're talking about the critical significance.
I told you there's something you check on the table. That is the T-tab. It's as simple as that. Your T value that you go and check in the table is your T-tab. T-tabulated. That tab means tabulated. The T cal is the calculated T. T cal. T calculated. Is that clear?
Yes, sir.
Yeah. You don't know you are wearing me out when you are not following my class and you are taking me back. It's not easy to teach. Any other issue? Michael. Is Michael there? Your first
Yes,
day
sir.
in this class, right?
No, it's not my first day, sir.
Do you understand?
Yes, sir.
Okay. Providence. Providence.
Yes, sir.
Is there anything that is a little bit shrouded in darkness in what we are saying here?
No, sir.
Success. Success.
Yes, sir.
Is success a guy or a lady? Hello? Success. Are you a male or female?
I'm a male.
You are a male. I'm hearing the female voice and I'm hearing the male voice at the same time. Are you doing conference call? Hello? So, how do we approach this question? Can somebody tell me in practical terms? What is the starting point here? You are giving this question. How do you begin it? How do you start? Can somebody just run through how we start?
Hello, sir.
Yes, Frank, go ahead.
Okay, it is to state the hypothesis.
Good. You state the hypothesis in form of statement and in form of words, mathematical expression.
Mathematics. Yes. Then you, secondly, you determine the alpha level.
So from this question, what's the alpha level?
Is 0.05.
0.05. Okay, Adriana, pick it from there. What is the next thing? What's the next thing to do? Number one, you have stated the hypothesis. Number two, you have determined alpha level. What's the next thing?
Locate the critical value.
Locate the critical value. How do you locate the critical value? How do you locate the critical value? Now, I taught you that there's what you call the Z table. I hope you still remember. I hope you still remember there's the Z table. Where we are going to check the other time. Are you with me? Hello?
Yes, sir, we are with you.
Yes, sir.
Okay. You remember there's a table called the Z table. You know, the same way we have what we call the T table. Is different from the Z table. Okay? When you go to Google, type T table, T distribution table, you will see T table. That is what we go and check when we are dealing with the T test. We don't go to a Z table. Okay? And remember, I told you that our T table, we have different formats. It is drawn. We have the one that it is the negative table that you see. if you are dealing with values that are on the negative side. Okay? If you are dealing with values that are on the positive side, you look up your value in your positive table. Is that one clear? Can we still remember all that? Can you recall all that?
The Z table is
Yes,
the
sir.
normal distribution table.
It's the normal distribution table. Okay? The T table is also a normal distribution table, but with a sample size less than 30. So it's a different table entirely. Okay? It's just like when I tell you that if you need anything, you can check inside the house. If you need to eat, it is kitchen, you go to room 1 and check when you enter the house. But if all you need is just snacks, you go to room 2. In other words, it's not as if you are hungry. You just needed something to be playing with. Okay? It is room 2 you go to. But if it is real hunger that is affecting you, it is room 1 you will get food. Am I making myself clear? Nobody is talking to you.
Yes, sir, we are clear.
Okay. So we have the T table, we have the Z table. Okay? Now, Adriana has just explained that we locate our critical value. How do we locate our critical value on the T table? How do we locate our critical value on the T table? Please understand, while using the T table, you need 2 things. You need information on your alpha level. That's number 1. And we say the alpha level is 0.05. The second thing you need when checking T table is your degree of freedom. That's the DOF. Degree of freedom. That's the DOF. Okay? And recall that here we are dealing with one sample test. Can somebody tell me what is the formula for calculating the degree of freedom for a one sample test?
N-1.
N-1, good.
Sample size -1.
N-1. Can another person tell me now what is the degree of freedom for this question we have on the screen?
7.
7.
The answer is 7. Good. The answer is 7. Okay. Now, when you go to your table, on your table, you are going to see things like 0.1, 0.05, 0.01. On the vertical or on the horizontal, you have something like this. I hope you are following me. Can you see my illustration on the screen? Can you all see the illustration on the screen?
Yes, sir.
Okay. On your T table, how do you check your T tab? Your T tab. How do you check the critical value? Your T tab critical value that I'm saying you should locate your critical value. That is also called the T tab. That is the tabulated T value. Okay? So the table looks like this. You already got the degree of freedom to be 7. Okay? Now you will go there. You will see the degree of freedom on the vertical column. You check it. And you check it under that alpha level, which is 0.05. The figure you see at this point, the number you see at this point is your T tab. Let's assume the figure you found there is 2.25. That figure is what we call your T-tab. Am I clear? Is this clear enough to you?
Yes, sir.
Locate your critical value. This is how to locate your critical value. You trace from up your alpha level and you intercept it with your degree of freedom. It gives you your critical value. It is the value that your calculated T must not exceed. If it exceeded it, you will reject your null hypothesis. Any question? Any question? Any question? Hello? Any question, please? No question. Now, you know what you do for me? This is one sample test. I've sent you the video of how to calculate one sample test. I've explained to you on the board step by step. Now, what you do for me is that this question on the screen, write it down now. This question on the screen, you will now go and calculate it. Okay? You will solve this question on the screen and turn in your answer before 8 a.m. to 8 p.m. today. The question on the screen, copy it down now. You will solve that question, get your final answer, make your conclusion, and turn in your work before 8 p.m. today.
Hello, sir.
Yes.
Hello, sir.
Yes, I'm with you. Frank, go ahead.
Okay, the standard deviation, hope is from these figures that we're going to get it because it's not given.
You are going to calculate it. What are you talking about? You will calculate it. The first thing to do is to ask yourself, what is the formula? What is the formula for your T statistic for one sample T test? Can somebody tell me? What is the formula? If you scroll backward, this is the formula here. Can you see the formula on the screen? Can you see the formula on the screen?
Yes, sir. Yes.
So it simply means you calculate the mean yourself. You make a table, calculate the mean. You have your H naught. Then what is your standard deviation? How do you calculate standard deviation? I taught you how to calculate standard deviation. So you calculate the standard deviation and then you substitute into this formula. Then
okay, sir.
You now know what you will get. What you will get now, you will compare it with this value. With this value, this is your T tab. If that value is greater than this, then you reject your H naught. If it's less than this, then you retain your H naught. Any other question? If there are no questions, I think we can call it a day.
Yes, sir.
Yes.
It is greater. To do what?
See it here. I've explained this over and over again. Look at it on the screen. If your T tab, see, are you looking at the screen? If your T tab is greater than your T cal. That T start is your T cal, is your T calculated. Call it T start, call it T cal, the same thing we are talking about. If it's greater, then you reject your what? Your H naught. You are rejecting your H naught. But I don't just want you to memorize this concept. I want you to understand the concept, the nitty-gritty. Let me go to that slide.
Yes, sir.
Yes. I'm with you. Go ahead.
Okay. I'm actually hope this particular question is two-tailed.
Yes, it's two-tailed. Is it two-tailed? Tell me. Is it two-tailed?
It's two-tailed because they're asking whether like if it varies from a given.
He said researchers are interested in whether the pulse rate of long distance runner differ from that of other athletes. It differ. At least not equal to. Then it is two-tailed, of course. It's a two-tailed test. It's a two-tailed test. It's a two-tailed test. So look at the screen now. Can you see the illustration I made here?
So I'm not
Okay.
seeing the screen.
You can't see the screen. Check the chat section. That's where we put it. Check the chat section. You see the screen is already sent to the chat section. So you will see T tab. If T tab is less than your T statistic, okay? Or sorry, it's greater than T statistic, you retain your H naught. But this is what it means in literal sense. It means if what you got in your T statistics, let's assume it falls here, you will discover that this value, this T critical is greater than it. That is when you what? You retain your H naught because it's within the non-rejection zone. But if the value of your T cal, that's the T statistic, the calculated T, falls within this rejection zone, what should you do? That's when to reject your H naught. Use this graph. This graph will help you. This curve will help you to know the decision to make. Don't just cram this thing. If you cram it, you are out. You may get confused. But if you understand the illustration, if the baby is sleeping, lying on his belly, feed him. If the baby is lying on his back, leave him alone. The screenshot is already there. The screenshot is already there.
Okay, hello, sir.
Yes.
I want to ask, like, in that T tab and T start, can there be any situation where they will be equal? They can be equal.
You see, we talk of less than. You see, that is less than it. It's very rare to have it exactly the same. Very, very rare. Let's not bring, it's a complication that we don't want to bring up now. But it's very, very rare. Okay? For it to be exactly,
Okay,
you know, these values are in decimal points. These values are in decimal point. There's no way you can get 1.96 exactly. You understand what I'm saying?
yes, sir.
There's no way you can get exactly. Usually in research, when it falls exactly like that, we repeat that research. We do it again. Okay? It's just like when you are saying in football, somebody shoots a ball and the ball now landed on the line of the goalpost. It's not inside, it's not outside. You know that thing is very rare in football. That the ball will land on the line, the goal line, that goal line. It's a rare situation. All right, so I think we are done for today. Please don't forget the assignment. Let's attempt it. You said?
Please display the question. I've not copied it.
You are wasting time. Oh, yeah, you have 1 minute to copy it now. 1 minute, please. Screenshot it. Just screenshot it with your phone. Swipe down, click screenshots, and that should be it. Or you copy from others that have copied it. So we are ending the class now. I have another appointment now. So the next time we are going to meet will be Monday morning. That Monday morning will also be what? What time now? That Monday morning will also be 7 a.m. Since it's a sit at home day, I won't be going for school run. So we still meet by 7 a.m. Please advise those that are missing the class not to keep harming themselves. I mean, enjoying themselves. They are really enjoying themselves, I must confess to you. Because I can assure you, if somebody did not participate in this, I can't pass this course. There's no way you can pass this course, except the person is already considering a receipt. And you know the receipt is even worse. Because receipt exam, nobody will teach you before you go back to exam. All right, thank you very much for your time. We'll come to the end of the class.
Thank you.
Thank you.
Thank you, sir.